Well, good morning and welcome to this brief little webinar on MQ Clustering. My name is Tom Dunlap. I am the presenter and have worked with MQ on many different platforms for more years than I care to admit, if you will. Presentation is kind of applicable to all platforms that MQ runs on. Not really going to not really going to favor any side. We actually use this, as you can see, in one of our own little classes on administration. It's like a supplement we use, okay? Now, as I go through, prefer that you use the chat to ask questions. It's just what all of our people have done in past webinars, as opposed to using the actual question location. Okay, off of our website, you should have been able to download the PDF handout. Go to www.themusinc.com, and when you get there, you'll see on the up towards the menu bar, you'll see webinars, and from there you ought to be able to find this one and find the PDF. It was made available, I believe, at 10 a.m. this morning, so you'll have the PDF. It's about 70 some pages worth of document. And basically you'll have that way everything that I'm going to be showing you. Okay, so let's go ahead and get started. Okay, so page 4, that little handout, this is the diagram, and kind of basically why do we even care about clustering? Well, one key reason is it makes it simpler for administration type people to administer MQ. The other reason is it becomes better for higher availability. So the reasons, if you will, it says queue managers, traditional topology, connecting all queue managers to each other directly. So if I had, as you can see, 6 queue managers and I wanted to interconnect them through, it would take basically, as it says, 2 channels for each queue manager, 2 transmit queues, some number of queue remote definitions between the queue managers. So if I had to define this, I would quickly end up with, pardon me here. Sorry about that. My allergies kicked in a little bit, unfortunately, just before I got started. So anyways, basically, I would end up with an awful lot of definitions to interconnect these things. It becomes a nightmare to maintain. If I need to add or take away queue managers, right, it becomes even more difficult to, start pulling things away. And also it's a way to do, as it says in the last bullet point there, right, a better availability of queue managers and to balance the workload across models. So in other words, I have not one queue manager that can do the definitions or do the processing, but I have several. Okay, and I'll kind of show you what happens a little bit later here. Okay. All right, so over to page 6. What is clustering? Well, I define queue managers. Now what I show you here, okay, is, and let me see here. Hold on, somebody did ask a question. I would prefer you folks do the chat. Okay. All right, that's fine, not a problem. Anyways, so back to the subject at hand. So in MQ, when I'm setting up a cluster, I need to have queue managers available. Now, I don't have a preference myself. These could be queue managers that are going to be dedicated to what is referred to as a full repository, or they can be queue managers that are doing both the functioning as the repositories and also doing real applications. What I'm kind of showing you here is standalone full repository queue managers, and two of them. And kind of the reason for two of them is just in case one breaks. So you're always best to have a minimum of two full repository queue managers. We give the cluster a name. Could be almost anything you want, and you'll see where that's going to be used in other definitions. Okay, but you give the cluster a name just for the, your own benefit, if you will. And again, the queue manager, we'll talk about what it takes to make them repository type queue managers. I have to define channels to interconnect the repository queue managers. I have to define transmit queues and things. We'll see all the definitions coming up. The idea behind it is I interconnect the two repository queue managers, and then they behind the scenes will talk to and share to each other and maintain each other's side of the full repository. Okay, so that way I have two full repositories that are always in sync, if you will. And that way, if one goes away, I can still, maintain resources within the cluster. Then we have some number of queue managers that participate in the cluster. And what I show you here is basically 4 queue managers. There really is no limit. There could be dozens of queue managers within a cluster. And we'll talk a bit more about some of the resources, a little bit later. So I have to, make those queue managers you'll see join. Now they become what's called partial repositories in the scheme of things. Okay, and I'm kind of showing you what I do is I connect, I define channels, and you'll see the channel definitions in each member queue manager, but it really is relating to one of the cluster queue manager or one of the full repositories. And the benefit here is I've defined 2 repository queue managers. I define only the channels and transmit queues necessary to hook up those 2. And when I want to hook up a member queue manager, I simply define the channel that relates to the repository queue manager you'll see. And again, I'll show you all the definitions in later foils. And it will then in turn automatically put together all the other things it needs, transmit queues, channel definitions, etc., to connect up and interconnect each of the member queue managers as they join the cluster. So that's really the advantage here. I basically only define the resources connected to full repositories, and then when I define a member queue manager, I hook it up to one of the full repositories, and from that point on, the MQ clustering process logic takes charge and puts in place all the definitions I need, you'll see, and remembers them all in the full repositories. Okay? Now, I kind of showing you balancing, if you want to think of it this way, the member queue managers across the 2 different full repositories. Purely a choice to you. No reason to do that, no need to do that per se. I can have everything pointed to one of the two, and the two full repositories will share with each other. It's just, where do I want this member queue manager to make and establish its connection to first? Okay? And we'll see some other benefits, if you will, as we go along. Bear with me here. Okay, oops. Yeah, I keep remembering I got to erase this thing. Okay. So here's an example on page 8 of hooking up the full repositories, or making the definitions. I'm going to show it to you, I believe, in a couple different ways. This would be the MQSC commands, or if you will, the definition, the character-based definitions to do with the MQ utility, to do it that way. The advantage of doing it this way is I would have text members that have the definitions in them, as opposed to using MQ Explorer. But I will show you the MQ Explorer, I believe, next page, in fact, okay, coming up. So right off the bat, in my two full repository queue managers, I alter queue manager attributes, and basically the repos option says this is a full repository, and I supply the name of the cluster that I want. And then the cluster, the CLWLU sequence is a parameter that's the it basically allows the things to perform round-robin balancing. In other words, the logical unit sequence of any allows the thing to balance the queues across all members of the cluster. Okay. Now again, it really is up to me if I want these things to be exclusively the no applications in there, or just be full repositories, or have queue definitions. Okay. Then you can see channel definitions, and again, pretty much standardized channel definitions, if you will, except kind of the widely accepted syntax for the names of the channels is to, period, and then the queue manager name. So as you can see, 2.mq0a is the cluster receiver type channel for the queue manager A. 2.mq0b is the cluster sender for B. So again, as normal MQ, I would have my sender relating to the receiver, right? And likewise on the other system, you'll see. Except instead of sender and receiver channels, these are now cluster sender, cluster receiver, which makes the difference to hook up the clustering. So pretty much standardized channel definitions like we've done many times over. Some of the other differences, we tell them that they're part of a cluster, okay? And provide host name. Now, as you can tell, host name and ports, right, are provided in the con names for all the channels. And again, as you can see, I'm using local host. When I put this thing together, we basically are hooking up queue managers that are all on the same server. So I'm not dealing with multiple servers here. They're all the, and when we do the class, typically, we would end up with maybe 15, 16 different queue managers all on the same server. So we're just not working with multiple different servers. So hence the local host. But you still need unique ports for all the queue managers. So that's what it takes to hook up the two full repositories to each other. define them as full repositories, and then in channels, make them cluster sender receivers, okay, and name the cluster, and then, the various host names and ports, okay? So the alter is what makes the thing a full repository, and of course the cluster sender is defined to this. Queue manager will automatically attempt to connect to the other one, and of course the cluster receiver, it says do that first. In other words, you got to have the receiver in place, because once you do the sender, okay, it's going to automatically try to hook up to the other queue manager. So you really want to define the cluster receivers first before you do the senders, okay? And of course, con names necessary in all the definitions. So the whole idea is two MQA, two MQB on one side, and same thing on the other side is kind of a naming convention used for the clustering. Normally, if we're doing normal MQ queue manager channels between two queue managers, not within a cluster, kind of the unwritten law is it's from queue manager period to queue manager name. So it's basically a combination of queue manager names. But because the definitions are going to be made totally by the cluster once this is all put together, this is kind of like what a lot of people tend to do. Just to.QManager name as kind of like the preferred name, if you will. Okay? All right, so over to page 10. Now, if you had MQ Explorer in place, and let me back up. I prefer the definitions. And that way I've got text files, or members on a PDS on the mainframe that I can go back to see all the definitions. Could I use MQ Explorer? And I'm in, I'm have selected queue manager attributes for a given queue manager, not showing you all the superfluous stuff. And then you'll see that there's a repository option in MQ Explorer, and I simply click the little thing that says this is a full repository of a queue cluster and give it a name. So I can do that, but I have no permanent record per se of what I've just done, unless you've got all the events turned on for configuration events and things like that. But then you have to have something that processes those events. Okay, so I could simply do it through MQ Explorer, choose the cluster option, and this is on page 12. Choose the cluster option. Oh, I just saw the question. I believe hold on here. Question box is being dumb. Okay, bear with me. Okay, folks are still using the question box, so we'll use the question box instead of chat window. Okay, So again, the question, do I need to refresh anything? No, basically it's just going to come straight in. If you add a queue manager to the cluster, it'll just join in and become usable right away. Bear with me, I'll kind of illustrate that on a later foil. Okay, so back to, again, page 12 in the book or in the handout. So I click on the cluster option, and now I can define the cluster name, and it's a full repository. Plus I can, as you can see, I can set up like a workload exit and what have you, things like that. But at the very bottom, you see the CLWL use queue, any. That's the option basically that says I'm going to do what's called round robin load balancing, which is probably what you want in a cluster. If you're going to define multiple queue managers, you're after high availability, you want multiple queue managers doing the work, you're probably going to want to have it do the round robin balancing. However, as you can see, you could write your own workload exit. I've seen most of the people I've dealt with, basically in the classes or in doing consulting assignments in companies, have stuck to the round robin balancing. It's just easier, right? Rather than do their own exits, but you could. Okay. So over to page 14. The other things I need to do is, in the general choice, define my connection name. Right? So this is the connection name for this queue manager. And basically, again, I'm doing localhost because I'm running it all on the same server. Okay. Over to page 18, or pardon me, skipped one, 16. On the extended, right, we're setting up like max message length, the heartbeats and things like that. Pretty much, everything is kind of normal here. 1 second. Sorry about that. Really don't need to, I did the non-persistent message speed to normal. It's about the only difference compared to default. The NPM speed is normally fast, and it's possible if we lose network connections, right, we could lose messages. By doing normal, it's going to do the, assured delivery type processing for even non-persistent messages. So I don't really lose anything as it's sending data. Now in our case, or my case in this example, it doesn't much matter, kind of, because every one of the queue managers is on the same server. So they're really not going across the network. But if I was sending between different servers, in different geographic locations, it would matter. So that's why I've chose the non-persistent message of normal for a better degree of integrity. Okay, now page 18. So the cluster, right? So basically, everything is being shared in the cluster. That's basically why I've chosen that. Okay. That we're, the main says that we must that the changes will be shared within a cluster. Okay. And page 20. And here on the general, this is again the other queue manager. So that's the configurations for queue manager A. This is queue manager B. So it kind of essentially the same thing, right? I have to set up the connection name. And again, everything's running here. Page 22, I set up the NPM speed on queue manager B. Okay, non-persistent message speed of normal. And I did that back on the channel definitions when I did the text. Page 24, okay. I'll get to that question in a second. Give me a minute here. So again, I supplied a cluster name. We're going to share the resources in the cluster. Okay, and that's pretty much doing it through Explorer. All right, now before I march on. Okay. So the question, and I hope I understand it, says, what if your application requires message sequencing? If you're dealing with message groups, right, and you're doing message group processing, I believe you're going to be fine. If you're doing your own setting of message IDs, you might have an issue, right? Because the round robin balancing is just simply going to be that. And I got a diagram coming up, so bear with me. Okay. All right, so now let's take a brief look here at definitions for the member queue managers. So I do not use the repository option. Okay. But I do set this sequence to any on any of the member queue managers. And basically that is what says we're going to do the round robin balancing and all the things. I define a cluster receiver for that queue manager. So each queue manager I'm going to have join the cluster, I have a cluster receiver. Specify the thing, npm speed, again, host name and port. Once those are in place, then I can define the sender to one of the repository queue managers. And the moment that that happens, it's going to try to establish a connection to those repository queue managers and put in place the rest of the things it needs. Okay? So that's why we define the receiver channels first. And again, cluster receivers. Because the moment we're going to put into place the senders, we're going to, in effect, right, cause it to hook up and away we go. So I'm just showing you 2 out of the 6 queue managers I had on the earlier diagram. Okay? And very quickly, through the next several slides, basically, this is the MQ Explorer form. I prefer the text stuff, but you'll notice it says not a cluster full repositories checked. So when I define it as a when I say it's not a full repository, it becomes a partial repository. So it's keeping its own little repository within the queue manager for all the resources that get put in place to hook and talk to the other queue managers. Okay? And of course, on page 30 is the cluster, and I leave out the cluster name. It's going to be a member of a certain queue manager. And notice what I've done is use the CLWL use queue of any to, again, continue the theme of round robin balancing. Okay? Define the host I connect to. And this is over on page 32. Okay, or my host name, I should say, for this queue manager. And of course, on the next page, 34, I've changed again the NPM speed to normal, so higher degree of integrity. And of course, the properties, I basically say we're going to share all the things in a cluster on the cluster definition, okay? So pretty much that's the MQ things. Now, why I included this is really should have been the queue manager E. I don't know why I repeated the A, but this really should have been queue manager MQ0E. But again, the same thing, right? I have to do the NPM speeds, right? And so on, okay? All right, so the other definitions, just text ones. I didn't duplicate things. Okay, so now we're up to page 46 in the handout. Okay. All right, now, so clustering resources. So the full repositories, these are the system definitions that are already in place or that come as part of the Q Manager implementation that you need. And you see I have the 2MQA, 2MQB, right? And I'm just doing one side, if you will, of the full repositories. But those are the resources that have to be in place, right, for clustering to work. And of course, the partial queue managers, they would have similar, right, the system default cluster sender receiver channels, the templates, and of course the command queues, history, and all that. But then I'd also have to define the 2MQC, 2MQA, right, the sender channels. So I have minimal definitions I have to make all this thing hook up, if you will. So here's kind of a example. And again, I'm showing you MQ Explorer. I have all of the queue managers in place, and you can see they're all sitting on a server. They're all really on the same server, okay? And then there are, when you see the cluster center receivers, you can see the repositories, everything's labeled as far as which is which are the full repositories, which are partial repositories. They're all labeled. You can see the queue manager type as a repository and so on. So once it's all hooked up, right, in MQ Explorer, you're going to see all the connections. And you'll see the queue manager clusters. It'll show you the cluster name and all the full repository queue managers and or partials within there. So I use all the MQSC commands and get the text files. But MQ Explorer will now show me, right, all the interconnection of all the resources. So I do use MQ Explorer to kind of look at things. Okay. Yep. Okay. Definition of queues. So page 50. Got to kind of pick up the pace here a little bit. It's supposed to be over at 11:15 or 12:15 rather, and I only got a few more minutes. So bear with me. So when I define a queue now, so I've hooked up all the queue managers. Now we got to define queues. Now, again, I'm showing you only 2 of the member queue managers. So I can have unique queues that are known to the cluster, but notice what it says. DF bind not fixed. Now, by having that option, it basically says wherever the application connects to, whichever queue manager the application connects to, that's where all the messages will go. Now that is the default. Now bear with me, I'll explain something else here in a minute. But basically I can define a unique queue, right, to the cluster, and with the default bind of not fixed, it's, the application would have to connect to that queue manager to get to that queue. So if I wanted to do qc.unique, I would have to connect to the QC. However, I can define the same name queue, make it known to the cluster. You can still see the bind's not fixed, okay? And because it's the common name, those are the ones that are going to participate in that round robin balancing. I can also have non-cluster aware queues, standard local queues defined in a queue manager, minus the cluster parameter means that the cluster don't care. So anything that has the cluster parameter, queue definition has the cluster parameter, it gets known to the cluster repositories, okay? If I have these unique queues that are known to a given queue manager like qc.unique, it's still known to the repository, but it knows that it exists only within MQ0C in this case. If I don't specify the cluster parameter, as in the last 2 queue definitions, it's not known to the repository. So I can still have queues that are part of a queue manager that are never known or never shown to the repository. So that's the only subtle differences. Now, one little comment is the bind is not fixed. So when I do this, I tell the programmers, right, they should also code bind not fixed, okay? I shouldn't say that, okay? Not fixed is the default, or what I coded. Let me backtrack. The default is bind on open, which means wherever the application does the open, whichever queue manager the application does the open to, it goes there. The bind not fixed, and I get the developers to do the same thing on when they do the MQ open. That's what allows it to do the round robin balancing. If you do not do def bind not fixed on the queue definitions, or if the developers don't do the bind not fixed option when they do the open the queue, you negate round robin balancing. Okay, kind of a subtle thing. The default is basically bind on open. So it's going to connect to a given queue manager and always use that queue. So it would never participate in round robin balancing. Okay, bear with me here. I got to keep switching this thing. Okay, so quickly I show you the same options through defining queues. I'm going to go through those fairly quickly. In fact, I'm just going to kind of fly through them. Okay, page 58. So defining queues, right? Pretty straightforward. The def bind option is important, and or have the developers do the bind not fixed on open, and then a cluster name, right? Now, if you have a common name, so here's kind of what shows you, and this is on page 58. So here's kind of what shows you is if I'm going to have a common queue, the same name queue, okay, and basically here I was doing it on a Linux server I have. So basically, if I'm accessing the common queue, message 1 would go here, 2 would go here, 3 would go there, and 4 would go there. So that's that round robin balancing. Doesn't matter where the application is connected to. Okay? The clustering would basically do the round robin balancing across all the queue managers that have that named queue. Now, somebody's asking about your own sequence numbers. If I'm going to do message groups, when you start to put messages within a group, it's going to go to a given queue manager. It's not going to split them across. It's not, in effect, doing message groups is going to kind of negate the round robin balancing because you're saying these messages belong to a group. But if I had an application that did group 1, then group 2, then group 3, the groups would participate in round robin balancing. Okay? If you're expecting to do your own sequence numbering, you're going to get these things spread because the clusters basically don't look at the message IDs or anything. It simply says, if I'm writing to queue.common, message 1 goes this queue manager, then the next, and the next, and just round robin balancing within the queue manager. Okay? Now it says if you delete queue common from a thing, which I can do, or add a queue manager without queue common, it's skipped. So if I took out queue common, message 5 would go here, message 6 would go there, message 7 would go there. That also is true if the queue manager basically has gone offline. You've taken a queue manager down. It would not participate in the round robin balancing. And that's kind of the other benefit, if you will, here of clustering. If you did this on your own in your applications, you have no way of knowing if one of the queue managers went away. Okay? And you'd have to have a way of doing your own round robin balancing. The clustering process knows if a queue manager's gone out of the cluster. It's exited it from the cluster because it went offline or something like that. When it comes back in, let me kind of clear these out. When it comes back in, it would rejoin and start to use it all over again. So if I added a 5th queue manager to the cluster here, I show 4. If I add a brand new one, the moment I hook up the channels to one of the repository, it would define the queue common in all the queues in the queue managers. Anything I would define unique would be unique, right? But the common name queue, it would replicate those definitions to the new queue manager and start to use it right away. So that's really the advantage, right? Clustering basically automatically knows which of these queues are common to all queue managers. And if I add a new queue manager, it will start using it. It actually will ship the definitions for the queue common to the new queue manager, start using it the moment I do the channel definitions, right, to hook into the cluster. So, all the interconnecting of all the channels, all the transmit queues between all the queue managers are automatically being done, plus all the common queues are being added automatically, okay? If I want to not participate, I simply have to delete the queue common from one of the queue managers, okay? And I kind of think I show you that on the next page. Yeah. So basically, cluster aware unique queue. If I were to put messages, right, to QC, I would be fine. But if I were to put messages to QC unique on a different queue manager, they actually end up getting routed. So the queue uniques, it doesn't matter, if I got a unique queue that's defined in a given queue manager, right, and it's just a simple matter of the name being done. If I connect to a different queue manager, like queue manager E in this case, and put messages, right, the cluster knows where QC.unique lives, and it's going to send it from that queue manager E to queue manager C. So the common name queue does round robin balancing, but if I have unique queues defined, right, it's going to send the messages to where the queue is physically defined. And notice what it says, queue remote and transmit queue definitions are automatically created. So I don't even define the queue remotes or the transmit queues. That's all being done dynamically because they're members of a cluster. Okay, so now I can have my applications writing to queues that live on a given queue manager. Now doing unique queues, even if, cluster aware unique queues, doing unique queues, right, you still have that single point of failure because all the data is still in QC.unique. If I have queues that are not cluster aware, they're only known to one queue manager, and the cluster has no concept of them. So that's kind of what I showed you when I showed you the queue definitions, right? I showed you unique queues on each queue manager. I showed you the common name queue, where it will do the round robin balancing, and then you have non-cluster aware queues, okay? And basically, that's how it kind of works. And in fact, on the next page is, on page 62 is a non-aware queue. So basically, I would have to connect to the queue manager where the non-cluster aware queues are known. So my application would be sensitive, right, to those queues being only in the queue manager that they connect to. And the cluster would have nothing to do with them, okay? So basically, no definitions, no queue remote or transmit queues are utilized, okay? Oh, one other thing I guess I should say, and let me back up a couple pages to the common queue. So I've gone back just to where it's the common queues. Same thing would be true for cluster aware unique queues. This is back on page 58. One more comment I do want to make. So if you do the round robin balancing, if that's one of the main reasons for doing clustering, okay, you have to have your application program available, right, to all of the queue managers in the cluster. Now, if I'm on the same server, not a big deal. But if I'm on different servers, that says my application must be distributed to all those servers. MQ doesn't know anything about that, right? But if you're going to have the application processing messages, your applications have to exist on multiple servers. The other thing MQ doesn't care about is any files or databases. So if I am going to have my own files and databases in the cluster, and these queue managers in the cluster for the applications to use, those files and databases have to be made available to each of the queue managers on each of the servers, or I should say on each of the servers so each of the applications can use it. Now, if everything's on the same server, right, not a problem. If, however, I'm working with different servers, that says I end up, replicating my files or databases. The distinct advantage here, if I'm working with something like a ZOS mainframe, is I can have a sysplex, and I can share files and databases within the sysplex. But that has nothing to do with MQ. Okay? So that's probably the only gotcha. If you're going to do clustering, MQ doesn't really care to do anything with your applications or files or databases. It's your responsibility to make sure that the application code, programs and files and databases are available to each server that you're going to have queue managers on that participate in a cluster. Okay? Clustering has nothing to do with your programs or files. Probably the only caveat to clustering. Okay? Okay. Now, some commands. Suspend a queue manager from a cluster basically removes the queue manager temporarily from the cluster. In other words, I may not want to have one participate for some reason in the round robin balancing. So then I can do resume whenever I'm done. The refresh basically does do the refresh, right, for partial queue managers. And that basically says I need to go back to the full repository to get my changes and definitions, okay? And of course, the reset is to basically remove, a cluster, queue manager from a cluster. So taking a queue manager out of a cluster, there's a sequence of events. Again, high-level overview. I'll be done here in a couple minutes. Bear with me. So first thing we do is reset the thing, right, to remove a queue manager from cluster or a queue from a cluster. You got to kind of follow these processes. You want to take a queue out, right? You have to set the queue attribute, right? So basically it does not have the cluster parameter. So I'm showing you queue common here, and I specify the cluster parameter as null. In other words, take it away, right? And it says on one of the things, ensure that the queue has been removed from a repository. So I can display the queue local and see if it's been taken away. Because it'll tell me if it, where it lives. Then you disable puts, alter a queue local, right, put disabled, and display it as necessary until the thing, all the messages basically have gone, drained away. Then I can finally do, right, in another queue manager, right, check for in-dot messages, and then once all the messages have been processed and removed from the queue, then I can finally delete it. So it's kind of a process to ensure that if I want to remove common queues, I go through a set process, okay? Hold on a second. Okay, I noticed that somebody said they can't download the PDF. I got to talk to my people. It was supposed to be made available automatically at 10 o'clock today. I really got to talk to my people and find out what the story is. All I can tell you folks is try again later this afternoon, right? Upon completion here, try again later this afternoon or tomorrow, because, I got no problem with you downloading the PDF. If it's not available, like I said, I don't know. I can't fix it right now. I got to get to my people and find out what the story is. So I would just say try again later. Go into the website, go to the webinars, and you should be able to get the PDF later on. Okay? All right. Page 68. Add a queue manager to cluster. Now, kind of showing you the Linux, Unix, Windows forms of the commands here, because that's where I was doing the class. Did it on a Linux server. So I can create a queue manager, right? And again, make sure the CLW, or user sequence of any is there, so it can do that. Definition of the channels, So I just want to add a new queue manager. I'm just adding channels, right? Again, define the receiver first, then the sender, and then define the queues. Okay, and then if I've removed a queue manager, I have to do the refresh. It's when I remove a queue manager from a cluster, right? I got to rebuild a partial. Once I do the new queue manager, once it hooks up to one of the full repositories, it's going to build a partial repository automatically. Okay, so it will bring it online right away. Removing a queue manager, right? Page 70. Bear with me, almost done. A little bit over, I realized. Stop activity for the queue manager, do the suspend, right? Remove the cluster receiver channel from use. I want to take a queue manager away from a cluster. Stop the channels, right? Delete the channels. Display the full status, make sure it's removed. Then I can finally stop the sender, delete the channel, and then when I do the refresh out of the full on the repository, it's kind of gone. So kind of the sequence of events. Okay, no workshop because we're not doing any kind of form hands-on, but the diagram, basically what I do is I hook up all the queue managers, kind of like I showed you at the start. So that is pretty much clustering and what it takes to implement. And what is the difference between refresh and reset? Refresh refreshes the repository. Reset is to reset. I'm trying to get back to the actual commands. The reset basically is to reset, to remove, forcibly remove resources from the cluster. Okay, back on page 64, if you've got the handout, apparently some people don't. So let me try to get here if I can quickly. Okay, here's the reset. So reset basically is taking away a force remove, in this case here, a queue manager from the cluster. In other words, I want to take it out forcibly, okay, because I got a problem with it or whatever. The refresh, as you see on the last page here, is to refresh the repository, right? Because I have done other removes like of channels or whatever. I'm just refreshing the repository to make the partial repositories in a queue manager update all of its resources. Get rid of that stuff, okay? That's all. So the reset is to forcibly take it out of the cluster for some reason. Okay, a little bit over, so I apologize for that. But like I said, please try the thing later on, and hopefully it'll get the people to get the PDF out there. So thank you for attending. Have a good lunch or whatever, finish over your lunch, and hopefully I've given you some information you can use. Take care. See you later.